The universe is incredibly vast, almost impossible to imagine. Our home, the Milky Way, contains hundreds of billions of stars, each with its own planets, quietly orbiting in harmony. Across the observable universe, countless galaxies stretch beyond what we can see, each holding billions of stars. And, among them, a few worlds may be just right for life, quietly waiting in the cosmic dance. Our solar system formed about 4.6 billion years ago. Before that, the universe had already existed for roughly 9 billion years. Plenty of time for life to emerge and evolve on other planets, or even for civilizations to develop. The light from the most distant stars, reaching us after millions or even billions of years, carries evidence of those ancient events and reminds us of the vast stretches of time in the universe. Distances in space are beyond ordinary human comprehension. A light year, the distance light travels in 1 year, is about 5.9 trillion miles. Traveling across a galaxy from edge to edge with today's spacecraft would take millions of years. Every encounter of light with interstellar dust, every glimmer from distant galaxies, is a fleeting signal telling the story of the structure and age of the universe. The observable universe is only a small fraction of what might exist. The concept of a multiverse, still hypothetical, suggests an infinite number of universes with different physical laws and parameters. Somewhere there could be universes where time flows differently, where space is warped in ways we can't imagine, and where life emerges according to entirely different rules. Even the structure of the Milky Way is staggering in its complexity. Spiral arms, star clusters, and clouds of gas and dust, where new stars are born, create constant motion and renewal. Yet most of the galaxy's mass is hidden in dark matter, which we cannot see or measure directly. This unseen influence shapes gravitational connections, holds stars and planets in orbit, and remains one of modern astronomy's greatest mysteries. The temporal scale of the universe feels infinite. The light we see today came from stars that formed millions of years ago. Stars that appear bright may have already died long ago. We observe the past, peering through billions of light years, giving the impression that the universe is both eternal and fleeting at the same time. Each galaxy is a world with its own laws, history, and destiny. Some galaxies collide and merge, forming new structures. Others remain unchanged for billions of years. The birth and death of stars, the formation of black holes, the decay of planetary systems, all unfold over millions of years and across distances so vast that they exceed human imagination. When we consider the probability of life, the scale of the universe is staggering. Billions of stars and trillions of planets create enormous opportunities for life to arise. Yet the question remains, if life is common, why don't we see evidence of it? This fact is both intriguing and unsettling, inviting philosophical reflection on humanity's place in the cosmos. In the dark depths of space lie countless phenomena that we are not yet able to explain. Interstellar clouds, cosmic dust, invisible galactic energy streams all form the fabric of the universe, which we only partially study. Each newly discovered structure raises more questions. What forms these objects? What forces govern their motion? And what role do they play in the evolution of cosmic systems? The light of stars traveling for billions of years carries information about the universe's past. We see the flashes of supernovae, the dazzling glow of quasars, and the faint shimmer of distant galaxies. Every photon is a message from the past, a testament to the endless cycle of birth and death, and within this process, humanity occupies a tiny but unique place. The universe's scale isn't limited to space and time. Energy and matter, the invisible forces of dark matter and dark energy, form the foundation of all that exists. We observe only the visible portion, while the rest remains a mystery. Perhaps our inability to fully comprehend the universe is part of its essence. The cosmos' grandeur cannot be contained entirely within the human mind. Every object, every star, every galaxy reminds us of how small we are, and yet how extraordinary our existence is. On the scale of the universe, even millions of years of our civilization are just a moment. And within that moment, we confront questions without answers and witness a beauty that can only be appreciated. The eternity of the cosmos reveals itself in the cycles of star birth and death, the formation of new planets, and the demise of old systems. Each process follows the laws of physics, which, though we study them, remain partially beyond our understanding. The human mind can only approximate these processes, building models and hypotheses, but each new mystery only expands our awareness of the unknown. It is within these scales and mysteries that the philosophical question arises: if the universe is infinite and full of wonders, why are we here? Why is our planet habitable, and what is our place in the cosmic network and structure? If the first part of our journey immersed us in the scale and infinity of the universe, now let's draw closer to individual worlds floating in this cosmic ocean. Imagine, each planet is a small experiment of nature, each with its own unique physical laws, history, and mysteries. On Mercury, temperatures swing from -290 degrees Fahrenheit at night to +800 degrees Fahrenheit during the day. It's as if the planet lives in two worlds at once, an icy desert and a fiery inferno. This extreme is due to its almost non-existent atmosphere, only a thin exosphere of sodium, potassium, and oxygen atoms, constantly knocked off the surface by solar wind and meteoroid impacts. This tenuous envelope is far too thin to retain heat or buffer the swings. Mercury has no clouds, no wind, just absolute silence. Each morning and night plays out like an eternal duel between ice and fire under a black sky. In this stillness, time seems to stretch, and the planet appears as a symbol of ultimate vulnerability in the face of the cosmos. If Mercury is the planet of extremes, Venus is its complete opposite. Here, there are no dramatic temperature swings. Beneath a dense shroud of clouds lies an eternal greenhouse inferno. The atmosphere is so thick that the surface pressure is 92 times that of Earth. For comparison, it's like being over half a mile underwater, where even steel begins to bend. But instead of oceanic coolness, sulfuric clouds and heat, reaching about 880 degrees Fahrenheit, enough to melt lead. Time flows strangely here. Venus rotates so slowly that a single day lasts longer than a year. Imagine an entire planet, where sunrise and sunset come less often than seasons change. Venus seems to mock our familiar sense of time, showing us that the universe does not have to conform to earthly expectations. Earth, in contrast to its neighbors, is like a finely tuned instrument. Here we have liquid water, a rare condition in the universe. The atmosphere not only provides breathable air, but also shields us from cosmic radiation. Plate tectonics, though causing earthquakes, refresh the planet by recycling carbon and stabilizing the climate. The magnetic field deflects the solar wind, and the moon stabilizes Earth's tilt, preventing the climate from spiraling into chaos. Millions of other planets remain barren deserts or hellish worlds like Venus. Yet here, on this tiny blue dot among billions of stars, life arose. Why are we the ones capable of observing, feeling, and reflecting? Every detail of Earth, from the tiniest droplets of water in the atmosphere to the vast oceans, forms a remarkably precise, harmonious whole that supports life. Earth becomes a window to the universe, an invitation to witness its wonders and appreciate the uniqueness of our place within it. Through this window, every moment of life becomes a precious affirmation of existence. Mars boasts the tallest volcano in the solar system, Olympus Mons, rising about 14 miles, and Valles Marineris, a canyon 10 times longer than the Grand Canyon. Its icy poles hide water, which scientists estimate could cover the planet in tens of meters if melted. Billions of years ago, Mars may have hosted rivers and oceans. Tiny microbes could have wandered its red soil, leaving invisible traces we are still searching for today. Jupiter is a true giant. Its diameter is 11 times that of Earth, and its mass is 318 times heavier. This is a world where the forces of nature go beyond human comprehension. The Great Red Spot is a hurricane the size of 3 Earths, raging for over 350 years. Jupiter's mysteries are not limited to its atmosphere. Dozens of moons orbit the planet, some of them entire worlds themselves. Europa and Ganymede are covered in icy shells, under which vast oceans may lie. These waters could be twice as deep as Earth's oceans, and in their darkness, life might exist. If life can emerge under such extreme conditions, beneath thick ice, in total darkness, under immense pressure and cold, might the universe itself be inclined toward life? Saturn is surrounded by rings made of billions of icy and rocky particles, ranging from tiny dust grains to boulders the size of small houses. This gigantic cosmic mosaic stretches hundreds of thousands of miles, making the planet one of the most mesmerizing objects in the solar system. Saturn has 83 moons, among which Titan stands out. Rivers and rains there are not of water, but of liquid methane and ethane. Entire lakes and seas of hydrocarbons create a landscape more akin to science fiction than reality. What is deadly to us could serve as a basis for life elsewhere. Perhaps in these cold methane seas, a completely different chemistry of life is at work, an alien biology beyond our imagination. Uranus literally lies on its side, its axis tilted almost 98 degrees relative to its orbital plane. This icy giant offers a glimpse into how diverse planetary evolution can be. Nearby, Neptune glows a deep blue. Winds there reach up to 305 miles per hour, the fastest in the solar system. No earthly hurricane can compare to such fury. The laws of physics are the same as on Earth, but the scales are beyond human imagination. Smaller bodies, asteroids and comets, carry the universe's record. Comet Churyumov-Gerasimenko harbors organic molecules, the very building blocks that may have given rise to life on Earth. For us, an asteroid impact is catastrophic, like the one 66 million years ago, but to the universe it is part of the natural cycle of creation and destruction. Every collision, every solar flyby, every journey through space is part of a grand experiment of nature that has been ongoing for 4.5 billion years. Exoplanets amaze and challenge our conventional understanding. Hot Jupiters orbit extremely close to their stars, with surface temperatures reaching 2,000 degrees Fahrenheit. One side is perpetually scorched, the other in eternal night. Super-Earths, 2 to 3 times the mass of Earth, have strong gravity that makes every step feel like carrying a heavy load. Some planets host water in all 3 states simultaneously, boiling, freezing, and evaporating at once. These worlds remind us that the universe is far richer and stranger than we can imagine. Planets are not just scientific objects, they are philosophical hints, teaching humility, wonder, and eternal curiosity. Their wonders always carry an element of the unexplained. Strict physical laws create order. Yet the astonishing diversity of worlds raises questions we cannot yet answer. Each planet reminds us that the universe is vast and mysterious, and our Earth is a unique oasis where life became possible. In this context, our place in the universe seems both small and remarkably meaningful. We can observe, understand, and marvel, feeling ourselves part of a grand cosmic pattern. Space is full of mysteries that ignite the imagination while confronting us with questions that have no definite answers, at least not yet. Take quasars, for example, the brightest objects in the universe. They emit more energy than billions of suns combined. But how is this possible? Scientists explain that at the heart of a quasar lies a supermassive black hole, millions or even billions of times the mass of the Sun. Matter falling into it heats up to millions of degrees, releasing colossal amounts of light and energy that reach Earth. We see quasars as they were billions of years ago because their light has traveled an incredible distance, like a journey through time. Yet, despite models and measurements, there are details science has yet to explain. Why do some quasars shine brighter than others? How are their jets, streams of energy shooting millions of light-years into space, formed? Each quasar reminds us that the laws of physics can create phenomena that seem almost fantastical. We can measure mass, rotation, speed, and luminosity, but a full understanding of how these objects form and evolve is still ahead of us. In this blend of strict science and the unknown arises a sense of infinite wonder at the universe. Black holes are not just cosmic vacuum cleaners. Their gravity is so strong that even light cannot escape, and some black holes are larger than our solar system. Matter accelerating inward reaches near light speeds, forming bright accretion disks that shine brighter than billions of suns. Scientists detect X-ray and gamma-ray bursts, measure rotation rates, and monitor disk temperatures that can reach millions of degrees. Yet what lies beyond the event horizon remains a mystery. These objects demonstrate that in space, time and space obey laws that appear almost fantastical, and the universe is far more powerful and mysterious than the human mind can fully grasp. There are strange, almost fantastical objects, pulsars. These are rotating neutron stars, remnants of massive dead stars, emitting radio signals with incredible regularity, like cosmic lighthouses guiding us through the darkness. Some pulsars spin at up to 700 rotations per second, about 42,000 revolutions per minute. Imagine this rhythm as the heartbeat of the universe, pulsating under the most extreme conditions. We catch their signals with radio telescopes, measure magnetic fields and radiation strength, and in these numbers hear an astonishing harmony. Pulsars remind us that even where order seems impossible, space can create stunning rhythms and maintain the flow of energy at the edge, demonstrating its grandeur through precision and beauty. Gravitational waves are ripples in the fabric of space and time. They arise when colossal objects collide, such as black holes, spreading across the universe at the speed of light. Detectors pick up tiny fluctuations smaller than the diameter of an atomic nucleus. We cannot feel them directly, but each wave carries the memory of events from billions of years ago, as if the cosmos whispers its history. This is a reminder that everything in the universe is connected, from the tiniest particles to giant galaxies, and that we live in a space that constantly breathes and moves, even if we cannot perceive it. What we see in the universe is only a small fraction of the full picture. Over 95% of space is made up of dark matter and dark energy. We cannot see it, touch it, or measure it directly. Yet its influence is undeniable. Galaxies rotate as if held together by invisible threads, and the universe expands faster than ordinary physical laws predict. Scientists study these phenomena through gravitational lensing, galaxy distributions, and the cosmic microwave background. Dark energy accelerates the expansion of space, like an invisible engine pushing the boundaries of the cosmos ever outward. We see only 5% of the universe. The remaining 95% remains hidden, yet it governs galaxy motions, cluster formations, and the destiny of the cosmos itself. This raises a profound question. If most of reality is invisible, how much do we truly understand about the world we live in? After stars die, planetary nebulae remain, gigantic clouds of gas and dust, glowing and shimmering in incredible colors. These clouds result from complex physical processes. Stellar gas ejected into space heats up from ultraviolet light of the remaining hot star and begins to shine. Every shape and hue has an explanation: chemical composition, cloud density, magnetic fields, and radiation effects. Yet, even understanding the physics, it's impossible not to marvel at the harmonious structures. Solar winds and gravitational effects turn chaos into astonishing patterns, as if the universe itself is painting. These nebulae remind us, science explains processes, but the beauty of their manifestation remains almost magical. The cosmos teaches both humility and awe. Supernovae, the grand explosions of old stars, astonish the imagination. In mere seconds, they release a mass equivalent to the Sun's, and their energy exceeds what the Sun emits in its entire 10 billion-year lifetime. From these cataclysms, new elements, carbon, oxygen, iron, gold, are forged, becoming part of new stars, planets, and life forms. The remnants of these explosions shine as nebulae or X-ray bursts. Supernovae are the breathing of the universe. They simultaneously destroy old worlds and create conditions for new ones, demonstrating a remarkable unity of power and beauty. Science can predict gas movements and flash temperatures, but the resulting colors and nebula forms inspire awe and remind us that we are witnesses to an endless cosmic cycle of birth and destruction. The universe is not just vast. It is incredibly complex, full of patterns and simultaneously mysterious phenomena. Each time we observe quasars, pulsars, or supernovae, we are not just recording light or radio signals. We are touching the grandeur of space, energies beyond imagination, processes that began billions of years ago, and eternal cycles of birth and destruction that create new worlds. We live on a tiny point in the universe where science and wonder intertwine, and every observed detail, whether the light of distant stars or the ripples of gravitational waves, reminds us of our unique ability to see, understand, and marvel. The cosmos is infinite, and we are its observers, capable of dreaming, asking questions, and uncovering ever more of its secrets. When we gaze at the night sky, millions of points of light remind us of the vast scale of the universe. And one question arises, a question that has puzzled scientists and philosophers alike. If life is possible in the universe, why don't we see other civilizations? This question is known as the Fermi Paradox, named after physicist Enrico Fermi, who famously asked, "Where is everybody?" At first glance, the probability of intelligent life seems high. Our galaxy contains hundreds of billions of stars, many of which host planets in the habitable zone. Yet life on Earth is the only example we know that evolved to intelligence. Does this mean we are unique? Perhaps on most planets, conditions either prevent life from forming or keep it at a microbial level. Scientists propose several explanations. One is the rarity of life. The emergence of life requires not only water and organic molecules, but also a stable planet, a suitable star, a magnetic field, plate tectonics, and the absence of catastrophic events. If even one of these factors is missing, the odds of developing complex life drop sharply. Another explanation involves the Great Filter, a hypothesis suggesting that there are extremely rare and difficult-to-pass stages in the evolution of life. These stages could include the origin of life from chemicals, the transition from single-celled to multicellular organisms, the emergence of an intelligent species capable of technological civilization, or surviving self-destructive threats such as wars, ecological disasters, or other global challenges. Philosophically, this presents a dilemma. The Great Filter could be behind us. We've passed the rare stages of evolution, or it could lie ahead. We have yet to reach the level of civilization that can avoid self-destruction. In this light, our responsibility to preserve life on Earth and to advance intelligent civilization becomes paramount. The Fermi Paradox also forces reflection on the scale of time. Galaxies have existed for billions of years. If intelligent life is capable of building technology, we should see traces of it. Radio signals, megastructures, signs of colonization. Yet all we observe is silence. This cosmic silence reminds us that the universe is vast, mysterious, and demands humility. Philosophically, this opens a path to understanding our place in the cosmos. We appear unique, and it is this uniqueness that makes us responsible. Earth is not only a cradle of life, but also a laboratory where we can study the laws of developing intelligent civilizations, assess threats and opportunities, and perhaps even intentionally guide our civilization to eventually seek or contact others. The Fermi Paradox is not just a scientific puzzle. It is a philosophical challenge. It reminds us that the universe's silence may reflect its immensity, our species, youth, and the enormous stretches of time we have yet to explore. Every scientific breakthrough, every new expedition, every radio observation program is not just research. It is an attempt to answer the question, can we find peers, or are we the lone observers in the cosmos? This thought evokes awe, wonder, and a sense of responsibility. We live on a rare planet, in a unique era, and each discovery brings us closer to understanding why we are here, and whether anyone else is out there. The Fermi Paradox reminds us, the cosmos is infinite and silent, and our existence is an extraordinary mix of chance, the laws of physics, and the grandeur of evolution. The cosmos is not only an infinite expanse of space, but also an astonishing dimension of time. Time in the universe flows differently than we are accustomed to thinking. Light from distant stars reaches us after millions, sometimes billions of years, revealing a past that will never repeat. In some theories, time can flow differently depending on gravity and the speed of moving objects. This raises questions that touch not only astronomy, but also philosophy. What is the present if we are always observing the past? Philosophers have pondered this for centuries. Immanuel Kant wrote that time and space are forms of our perception, not absolute realities. Yet the cosmos shows that perhaps this is not only a human perception, but a reality where past, present, and future intertwine on unimaginable scales. Black holes and the warping of space-time can literally slow down time. If we approached the event horizon of a black hole, our clocks would tick slower than on Earth. This is not science fiction. It is the law of physics. At the same time, it raises a philosophical question. What is time if it is relative and impermanent? Our everyday life shapes the sense of time as constant and uniform, but physics shows that time is not an absolute measure. Space itself is not empty. Even in the emptiest regions, microscopic fluctuations of energy constantly occur. Sometimes they manifest as tiny particles and antiparticles, appearing for fractions of a second before vanishing. These processes happen continuously, invisible to us, yet they reveal that the universe never stands still. It is like a quiet whisper of the cosmos, reminding us that even where nothing seems to exist, events unfold hidden from our eyes, and the laws of nature are full of mysteries and wonders. Time and space in the cosmos can sometimes appear paradoxical. Hypothetical wormholes, tunnels that could instantaneously connect the farthest corners of the universe, represent a theoretical possibility we have yet to observe. It is as if the universe itself conducts a philosophical experiment, showing that the laws of nature can be strange and unpredictable, and that reality is layered and full of mysteries. If space can be warped and connect locations that seem distant, could this mean that our ideas of boundaries, time, and place are illusions? Perhaps the universe is hinting that we cannot fully understand it, and therein lies its hidden beauty. Galaxies are not merely drifting apart. They are accelerating, moving faster than early astronomers expected. Billions of stars and entire galaxies seem to float along an invisible river, and we perceive this through light that has traveled billions of years to reach us. This mystery is linked to dark energy, a mysterious force that pushes the universe, causing it to expand. We observe its effect on galactic motion, but we still do not know what it is or how it works. If the universe is infinite and full of hidden processes, our sense of time and our existence is just a tiny point within the grand fabric of reality. As Albert Einstein wrote, time and space are not eternal truths, but illusions that fade when we look at the universe in its fullness. Even the most familiar phenomena in the cosmos can inspire philosophical wonder. Spiral galaxies, enormous systems rotating for billions of years, maintain their shape and order. We see harmony, yet behind it lies an unseen force holding billions of stars in orbit. This is both a scientific fact and a philosophical puzzle. How does the universe maintain structure and order? Space and time are not just a backdrop for life. They are active participants in cosmic processes. Every object, a star, a black hole, a galaxy, contributes to the motion and evolution of the universe. We observe their interactions, yet full understanding remains beyond our reach. Did you know that the human eye can distinguish only about 6,000 stars in the night sky? In reality, our galaxy, the Milky Way, contains between 100 and 400 billion stars, and the observable universe holds hundreds of billions of galaxies. Every visible point of light is not just a twinkling object, it is an entire cosmic story, from the birth and life of a star to the possible formation of planetary systems. When we look up at the sky, we are peering into ancient epics and scales that our minds can barely comprehend. Our instruments allow us to see the unseen. X-ray and infrared telescopes reveal objects hidden from ordinary sight. With their help, astronomers have discovered neutron stars, black holes, magnetic fields, and radio pulsars that emit signals with precision far beyond any human technology. The scales are phenomenal. Some galaxies lie more than 13 billion light-years away. That means the light reaching us began its journey almost at the moment the universe itself formed. We see them in the past, not the present, as if peering into the ancient history of the cosmos. The human brain never perceives the cosmos directly. We see only an interpretation of the signals it receives. Light hitting our retinas is experienced as color and brightness, yet the photon streams themselves remain invisible. Radio waves from cosmic objects are picked up by antennas, and our brains interpret them as numbers and graphs, not as sound. Everything we know about the universe passes through the filters of perception and the limits of consciousness. We do not see reality itself, only its shadows, clues, and reflections, which scientists learn to decode. As Carl Sagan wrote, "We are made of star stuff. Every atom in our bodies was once part of an exploding star." This is not just a scientific fact, but a profound philosophical reminder of our inseparable connection to the cosmos. We are not merely observers of the universe. We are part of it, living witnesses to what was once the fire of stars. And yet, much remains unexplained. Fast radio bursts, mysterious dark galaxies, and other enigmatic phenomena still defy precise explanation. They remind us that the universe is far more complex than it seems, and that our science is merely a delicate attempt to lift the veil on its secrets and touch its infinite mysteries. Philosophers have reflected that the invisible processes of the cosmos are like a mirror for human consciousness. We seek order, try to understand patterns, yet face infinity and randomness simultaneously. Perhaps this is the essence of the cosmos, a mixture of order and chaos, the known and the unknowable. Our technologies advance. We study galaxies, planets, comets, and asteroids. Yet even the most precise models cannot fully explain why the universe is exactly as it is. This gap between knowledge and mystery is what has inspired astronomers and philosophers for centuries. In the end, we realize that observing the cosmos is touching infinity. We measure the light of distant galaxies, calculate the masses of stars, observe the flares of quasars, and all of this reminds us how small and yet how significant our role is. We are not just looking at the universe, we are part of it. In this eternal pursuit to understand, discover, and measure, the true wonder is born. To be alive here and now, on this tiny blue dot, in a world that is both strict and unfathomable, immense and astonishingly harmonious. Did you know that it's possible we are not alone in the galaxy, yet we fail to notice other civilizations? Some hypotheses suggest that intelligent beings may consciously avoid contact with us. This idea is called the zoo hypothesis. Just as we observe animals in a wildlife reserve, more advanced civilizations could have placed humanity under observation without interfering. The philosophical aspect is clear. If someone is watching us, we become part of an experiment or lesson, and our reality is simultaneously free and constrained. It makes us wonder if the universe is structured differently than we imagine, and whether our ability to observe is only a small part of a much larger picture. Scientific evidence has not yet confirmed the existence of such civilizations, but the cosmos is full of unexplained signals and phenomena. Radio waves from distant sources, strange temporal anomalies, unusual flashes of light. All of these could, from a philosophical perspective, be traces of alien presence. Exotic explanations go beyond conventional understanding. Some scientists propose that life forms could exist in states beyond our perception, in another dimension, as quantum fields, or as energy rather than matter. We cannot detect them yet, but their influence could be hidden in the structure of the cosmos, in the motion of galaxies, or in microscopic energy fluctuations. Imagine that the universe is a living organism, and we are just one of its visible organs. The fact that we do not see the other organs does not mean they do not exist. This is a philosophical reflection on the nature of reality. What is hidden can be just as important as what is accessible to study. And again, as Carl Sagan wrote, the cosmos is full of wonders, and the more we learn, the more we realize how little we know. Perhaps we are only observing the first layer of a multi-layered universe, and the mystery of an alien presence remains unsolved. Thus, the zoo hypothesis and exotic explanations are not just scientific theories. They are a philosophical signal. The cosmos may be far more complex than we imagine, and our place in it is both unique and profoundly mysterious. Did you know that space is not just dots of light against a black background? Nebulae, spiral and elliptical galaxies, create incredible patterns and color spectra that astonish the imagination. Red, blue, and green hues correspond to the emission of ionized gases, red for hydrogen, blue for helium, green for oxygen. It is the interaction of photons with free electrons and atoms that produces these colors, which we detect using spectroscopy. Every flash, every gleam, is a testament to nuclear fusion inside stars, where light elements transform into heavier ones, releasing energy as visible light, ultraviolet, X-rays, and infrared radiation, allowing us to study the temperature and composition of stars millions of light-years away. When we observe nebulae, like the Eagle Nebula or the Crab Nebula, we see clouds of gas and dust expanding at speeds of tens of kilometers per second. Their light carries information about the density, temperature, and chemical composition of the gas. Spiral galaxies, like the Milky Way, rotate at hundreds of kilometers per second, and their spiral arms form due to density waves compressing gas and triggering star formation. Elliptical galaxies are nearly devoid of gas and dust, their stars old and dim, yet each is an archive of billions of years of cosmic history, where stars age and evolve into white dwarfs, neutron stars, or black holes. By observing these objects, we are essentially looking into the past. Light from nearby nebulae reaches us over hundreds or thousands of years, while light from distant galaxies takes billions of years. This is why astronomers can map the evolution of the universe. In this context, the laws of physics create order and predictability. Gravity forms stars and galaxies, electromagnetic forces govern light emission, and nuclear reactions inside stars produce energy and elements essential for life. Imagine a slowly unfolding nebula. Gas and dust heated by young stars create shimmering patterns that may last millions of years. Magnetic fields guide the motion of charged particles, while turbulent flows form dense regions where new stars are born. Every detail, from a hydrogen atom to tiny dust particles, participates in a complex dance of physical laws, creating an astonishing harmony that we perceive as beauty. A meditative feeling arises when we gaze at distant galaxies. Spiral arms in the cores of elliptical galaxies show how gravity and dark matter shape the structure and motion of countless stars. The light from these galaxies has traveled billions of years to reach us, so we see them as they were in the distant past. Every ray of light is a stream of information about time, space, and physics, which we perceive here and now, prompting reflection on the vastness of the cosmos. Even the spectra of light hold mysteries. Ultraviolet, infrared, and X-ray emissions are the language of the universe. X-ray telescopes like Chandra capture flares from accretion disks around black holes, while infrared telescopes like James Webb allow us to see star formation in dusty clouds invisible to the human eye. We measure gas temperature, rotational speeds, elemental composition, and density, and each new fact expands our understanding while generating even more questions. As Immanuel Kant wrote, "The beauty of nature is the visible harmony of the law." In space, this harmony can be felt in every color of a nebula, in every rotation of a spiral galaxy, in every supernova explosion. Science explains the processes, but contemplation allows us to feel the grandeur and complexity of the universe. After traveling through billions of light years, across spiral and elliptical galaxies, we gradually return to Earth. Our planet is a tiny dot on the cosmic scale, with a diameter of only 7,918 miles, while the Milky Way stretches 100,000 light-years across. Here, life as we know it developed. We are a small spark in the universe. Each life is a fleeting moment in 13.8 billion years of cosmic history. Yet it is precisely these moments that create meaning and beauty in our existence. Even the millions of stars we see in the night sky, at distances ranging from tens to billions of light-years, remind us that we are part of a vast and mysterious world. The Sun, with a mass of about 4 octillion pounds, illuminates our planet, and its light reaches Earth in 8 minutes and 20 seconds. We feel our connection to the cosmos through the laws of physics that govern planetary motion, galaxy rotation, and the expansion of the universe. Even if we never reach other star systems, studying them shows that the cosmos is a source of science, inspiration, and philosophical reflection. Returning to Earth, we sense harmony, awe, and a gentle meditative calm. The visible universe is only about 5% of the whole. The rest is dark matter and dark energy. And though much remains a mystery, that is precisely the beauty of it. We can study, reflect, and contemplate, feeling our place in the infinite cosmos. And as you drift through this endless cosmic harmony, let each sparkle of light remind you that you are part of something vast and beautiful. If you enjoyed this journey through stars and colors, leave a comment to share your thoughts or feelings. And to join us for more gentle meditative travels across the universe, subscribe to the channel and stay with us in this calm, luminous cosmos.